Welcome back. In this section, we learned all about linked lists. We learned how it doesn't come pre-built in a lot of languages, such as JavaScript, but it does in others. That is because linked lists are low-level data structures. It's used a lot actually in other data structures like hash tables, and as we will see in some of the upcoming ones, such as stacks and queues that we're going to talk about. It is a fundamental data structure that is very, very useful in computer science, and also a very popular question when it comes to interviewing. We learned that when it comes to linked lists, there's no random access in the sense that when looking for something, you have to actually traverse the list. With hash tables, we can find things right away. With arrays, we can find things through indexes. We have slow lookups. We have to traverse through the list if we're searching for something. However, they are ordered, unlike hash tables, and linked lists allow us to have this sort of order. If we had a large number of items in an array, and we keep adding to that array, we'd have to have excessive overhead costs copying the array in memory and doubling up the space when it reaches the limit to create a larger array. Versus a linked list where we can have a fast insertion and fast deletion, especially once we have a reference to where we want to insert or delete that node. This also becomes really, really fast when it's at the beginning of a list or the end of the list. And we're going to see that coming up when we talk about stacks and queues. The primary reason to choose a linked list over something like an array is simplicity and ability to grow and shrink as needed. Now, working with them, as we saw, can be a little bit weird and difficult to just manage all the pointers in your head, but they are pretty lightweight and self-contained in that they can be quite flexible as well. That's why you're going to see linked lists in a lot of places, like implementing file systems on your computer, or even browser history, right? When you go back and forth on a browser, you can think of that as a linked list because you can traverse one by one from one place to another. And remember with our hash tables, how we had this issue of collision. And when we had a collision, we had to do something like this, where we combined John Smith and Sandra Dee into two nodes, and the first node pointed to the second node. If we go back to our hash table data structure that we created, if we scroll down to the set method, where we set a key and a value in the hash table, we did a check here to check if this address exists, and then afterwards, we used an array to push our items in case we had multiple items when we had a collision. Because sometimes we can set our hash table memory size to be a lot smaller, like 2. And you might be able to see why now, instead of using an array, which every time we need to insert a new item, it works because we're pushing to the end. But if we had to delete an item on the hash table, we'd have to unshift the array, which, as you know, is very slow. So we can modify this now to something like a linked list so that a delete becomes a lot easier than if it was an array. And that's something that I'll leave up to you. But you should have a good sense of why these data structures exist now and why you might want to use a linked list over an array. We also added another piece of the puzzle in our mind map. We've talked about arrays, about hash tables, and now we talked about, if you see over here, linked lists. Our singly and doubly linked lists with their big O notation. And just a hint here, as you can see, linked lists are related to something we're going to talk about coming up. That is trees and graphs. But at the end of the day, we've just managed to add another data structure to our tool belt as engineers. Congratulations, and let's learn about more data structures in the next video. Bye-bye.